All right, well, welcome everyone to the National Association of State Energy Officials webinar on moving the market for direct air capture forward. My name is Kelsey Jones, and I'm a program director here with the electricity team at NASEO. So just for some background and level setting, many state energy offices across the country are exploring opportunities for direct air capture in their states and regions. And state energy offices really play an important role in facilitating supportive policies and programs to help move the market for direct air capture forward. They're also responsible for developing comprehensive state energy plans, as well as some more focused materials such as roadmaps or reports on topics such as carbon management. Last month, NASEO led a delegation of 9 state energy officials to Iceland for a visit with industry and government officials on direct air capture and storage. And really, the goal of this visit was to help states improve their understanding of direct air capture and the sort of necessary policy, programmatic, and planning considerations to help grow the market in the United States, and also to strengthen the feedback loop between states, the US and Icelandic government, and key industry partners. And so the goal of this webinar is really to build on some of the information shared at that visit. And as part of some additional work NASEO will be engaging on in the direct air capture space, we'll be developing an issue brief for state energy offices, as well as hosting a domestic workshop next year on DAC. We've really seen that as states seek to utilize federal funding and incentives to accelerate deployment of direct air capture across the country, there are questions out there on technology readiness, policy and regulatory barriers, and opportunities, and how to best engage with different stakeholders. So at this workshop next year, we hope to foster stronger communication and partnerships among states, DOE, and the private sector, accelerate market opportunities, and help states streamline the policy and regulatory process for RD&D around direct air capture. And just some quick logistics. You can move to the next slide, Camille. So this webinar will be recorded, and the slides and recording will be shared with all registrants, as well as posted on the NASEO website. And we really encourage folks to participate in the discussion portion following the 2 presentations. Please add any questions to the Q&A box at the bottom of your screen, and we'll address those at that time. If you do have any technical issues or questions, feel free to message myself or my colleague, Camille Norton, and we'll help get that straightened out. And now, before I introduce our 2 speakers, I just wanted to take the time to thank the U.S. Department of Energy's Office of Fossil Energy and Carbon Management for their support of this webinar. So with that, I am pleased to introduce our 2 speakers today. First, you'll hear from Grant Faber, Direct Air Capture Hub's Program Manager with the Office of Fossil Energy and Carbon Management at DOE, followed by Andrew Fishbane, Lead Government Affairs North America with Climeworks. So with that, I'll hand it over to you, Grant, to walk through your presentation.
All right. Well, thank you, Kelsey, for the introduction. And yeah, thanks to NASEO for hosting this. And yeah, we'll have some good conversation and hopefully have a little bit of fun as well. So, okay, so let me share here and yeah, get into my slides. So yeah, so today I'm going to talk a little bit about the direct air capture activities going on at DOE, different ways people can get involved, and just some other interesting topics and such that are on everybody's mind, specifically surrounding the DAC hub. So I actually just want to start the presentation just by kind of level setting and showing where FBCM, where the carbon removal efforts sit within the federal government. So this is an organization chart for the overall Department of Energy. And you can see that there are these kind of high-level tranches where you have the Undersecretary for Nuclear Security and National Nuclear Security Administration. So this is the semi-autonomous branch of DOE that deals with our nuclear weapons stockpile. And so, yeah, they're part of the Department of Energy for various reasons, but often kind of do their own thing. And then in the middle here, you have 2 different tranches. You have Undersecretary of Science and Innovation, where my office, Fossil Energy and Carbon Management, sits. You have Undersecretary for Infrastructure, where the Office of Clean Energy Demonstrations sits, Grid Deployment Office, State and Community Energy Programs, which I'll touch on later, and which some of you in the audience may have interacted with before. And then there are a number of other staff offices that support the overall functioning of the department. But yeah, so we'll zoom in on fossil energy and carbon management real quick. So this is the sub org chart for our office. And so, yeah, you can see we have kind of at a high level, Office of Carbon Management and the Office of Resource Sustainability. And zooming in within the Office of Carbon Management and Office of Carbon Management Technologies, we have a number of different technology areas covered: point source carbon capture, carbon transport and storage. But as you can see, there's the CO2 removal division where I sit. So within our little corner of the federal bureaucracy, we have this vision statement of advancing diverse carbon dioxide removal approaches. I'll speak a little bit more about the different approaches that we focus on in the following slide. But yeah, we want to advance all kinds of carbon removal approaches in service of facilitating gigaton scale removal in the United States, while emphasizing the general and broad environmental impacts of these systems. That includes both the emissions that are generated from carbon dioxide removal systems that offset the amount of gross capture from the atmosphere that is created, but also other kinds of environmental impacts from these systems, whether it's water use or land use or resource consumption and so forth. So yeah, I want to keep all those things in mind as we are scaling up this portfolio of technologies, while also keeping in mind environmental justice and the social impacts and benefits of these technologies. So sometimes how I frame it is, if it's like the whole reason we're trying to mitigate and ultimately reverse climate change is for people. If we harm people, if we harm society in the course of doing these interventions that are necessary to mitigate climate change, then are they really worth doing? So we definitely need to do this right, do right by the people and the communities in which these projects will be deployed. So that's our overall vision statement. In terms of funding, so we have base appropriations. That's just like the annual level of funding that we get for our various programs of maybe around $70 million. It fluctuates. And the most recent Senate marks have us at about $80 million. But yeah, it's maybe around that level. So that's what we get to distribute every year. But then additionally, funded primarily from the bipartisan infrastructure law, we also have input in and influence over in the $3.5 billion direct air capture hubs program, $115 million DAC and CDR prize competitions, which I'll touch on a little bit later, and then some related programs going on across the Department of Energy. So that's just to give a little bit of context on the kind of funding that we're usually dealing with. In terms of key partners, so it's hard to be comprehensive here because DOE and FECM do work with so many different partners across the federal government, but probably our key partner is the National Energy Technology Laboratory, and specifically their CDR program. I'll actually go back a slide a second. So if you look up here in the top right, you'll see the director of the National Energy Technology Laboratory. And NETL, as we call it, is one of the 17 national labs within the DOE system, but it is the only one that is both government owned and government operated, whereas other national labs are government owned and contractor operated. So given NETL's special status as the only government operated national lab, there's a very deep and close relationship between FECM and NETL. And so we work very closely together on all of our programming. So they're kind of our key partner in doing intramural or internal R&D efforts, which could be things like discovering new direct air capture sorbent formulations, as well as implementing our extramural or external programs. So they might, for example, do the day-to-day project management for our DAC Hub awardees. So just wanted to call them out there, and I'll talk a little bit more about one of their programs later. But we work with other agencies across the federal government. For example, EPA, which oversees geologic CO2 injection permitting and such. NOAA on ocean carbon removal, USDA on biomass carbon removal, and so forth. So we really try to engage with a wide number of stakeholders. And so I just want to spend a couple of slides quickly talking about carbon dioxide removal and DAC and kind of where they sit and why we're doing them. A lot of you on the call will probably already be familiar with this data and have seen these graphics and reasoning before, but just want to note, this graphic on the top comes from FECM's strategic vision document, and shows just a rough estimation of what the United States' so-called hard to abate emissions are. So these are emissions that either it would be, overly expensive to try to reduce them or completely eliminate them, or we may not have existing technically feasible pathways to do so. But we still have to reach net zero, because if we don't reach net zero, then CO2 is going to continue accumulating in the atmosphere. So for these hard to abate emissions, it may be economically optimal to compensate for them using carbon dioxide removal. So on the bottom here is a graphic showing different approaches to carbon dioxide removal. On the left here, you have direct air capture with storage, which is primarily what I'll be talking about today. We have a number of other pathways available to us that can help us take CO2 from the atmosphere and then lock it back up in the long carbon cycle. And so this, in the near and medium term will help us reach net zero, and perhaps in the long term will help us actually go net negative and begin the long process of reversing at least aspects of climate change. So just a quick note that the top figure here is a US centric figure, but countries around the world are also going to struggle with hard to abate emissions and are also looking at carbon dioxide removal. So just quickly to this slide, I mean, a lot of you on the call will probably be familiar with this, and maybe Climeworks will talk about this in the presentation, but just a quick, super high level overview of what's going on with DAC. Essentially, you use low carbon energy to power these direct air capture systems. They separate CO2 from the ambient air, generally putting it into a more concentrated stream, which can then be utilized in products. It can be reacted with things like concrete, or it can be injected underground for long-term storage. So just in case anybody on the call wasn't as familiar with what's going on here, this is what DAC is. It's a very brute force way to just tackle climate change, and so it's the main challenge is that it's fairly expensive. But a lot of our efforts are focused on rapidly getting the cost down so that we can have this as an option as a cost-effective option for carbon removal and reaching net zero. So on this side, I want to talk about, what's the kind of overall spectrum of the Department of Energy's DAC work. And so, often how we're thinking about it is we want to support technologies across the entire portfolio, regardless of if it's just an idea in someone's head, all the way through to a pilot or demonstration scale facility that's trying to build it to actually remove CO2 from the atmosphere at scale. And we kind of need to support the whole basket of these technologies to ensure that the whole space moves forward together. So at these low technology readiness levels, maybe around 2 or 3 out of 9, and we can talk more about what TRLs are in the Q&A if anybody's interested. This is kind of, early stage materials development. Most things in DAC, I mean, in terms of the cost, energy use, equipment needs, and so forth, they all stem from the fundamental properties of the material that you are using. So developing a good material that can actually react with CO2 in the ambient air is key. Once you have a good material, you can move into larger so-called structured material tests and integrated bench scale systems. This is where you might, instead of just having a little powder in a jar, you might formulate a sorbent or a solvent in a more industrially relevant form factor, for example. So instead of just testing a little powder, maybe you have a laminate, maybe you coat it onto a monolith, and then you maybe test not just the uptake of CO2 from the ambient air, but maybe also its desorption, which is when you, in a controlled environment, take the CO2 back off of those materials for subsequent use or sequestration. So it's kind of stepping up there. The next stage would be, okay, once you validate a material there, we want to move to a pilot scale demonstration. Can you actually capture hundreds or perhaps thousands of tons per year from the atmosphere with this facility? End to end, does that system actually function and work as intended? And then maybe you would do a FEED, which stands for front end engineering design study. So you can do pre-feeds or feeds where you're doing the engineering work for even larger scale facilities. And then finally, these larger demonstrations, which we're hoping that we will see through the regional DAC Hubs program, which I'll talk about shortly, where it's not just hundreds or thousands, but we're talking tens of thousands, hundreds of thousands, perhaps millions of tons of CO2 removed from the ambient air per year with these facilities. And that starts to be a much more commercially and industrially relevant application and scale. So underlying all of these different steps, we're very focused on techno-economic and life cycle assessment, which respectively cover the costs and environmental impacts of these systems, process modeling, systems analysis, how do these things plug into broader clean energy and storage availability, and how are we going to have the workforce to do this? These are going to be major industrial installations. So do we have the people that are necessary to staff and run these things and to continue innovating in this space? So DOE's kind of, we're dabbling in all of these different areas, which is super difficult, but very exciting. So I just want to share this quick program schedule here. This is just, it's very rough. We're fine tuning this, but this is just showing how, the past few years, we've been maybe more focused, just given the readiness of the industry, on materials, the bench scale kind of stuff. But then with time, we're going to move into larger pilots and feeds and these demonstration scale projects. So on the following slides here, I'm just going to talk about a few of our programs that might be of interest. So probably the most exciting one, just given the level of funding, is the regional direct air capture hubs, which are funded by the bipartisan infrastructure law. So this slide, I'm just sharing a few provisions that are applicable to these hubs. So they're supposed to be geographically diverse. Each one is supposed to theoretically be able to remove 1 million metric tons a year from the atmosphere. The hubs, just based on the original legislative language, are targeting areas that have current or retiring carbon-intensive fuel production, high employment potential. It can scale in those areas to the megaton scale or beyond. And there's a focus on economically distressed communities, perhaps ones that have significant quantities of fossil fuel resources. So kind of part of the strategy here is that these areas are such areas, or maybe with existing fossil production, are maybe more likely to have the kinds of infrastructure necessary to transport and to sequester CO2, likely to have the workforce for those things. But also, if we start to think about maybe a managed phase out of fossil fuels, direct air capture could be something that allows for continued employment opportunities in these regions. So that's just how we're how we're thinking about this, and maybe how this program was initially structured. So in terms of the actual progress here, so 4 megaton scale hubs, was the original congressional intent. It's a very, very ambitious target, particularly given the current readiness of the industry. So the approach was to issue like a fraction of the funding to begin with, to help the industry get to the point where we could have a more realistic shot at establishing these hubs. So in August of 2023, 21 different project selections were made. The first topic area were these feasibility studies, a few $1 million just at 14 sites around the country to explore what would a hub actually look like in these areas. Second topic area was feed studies for these larger scale hub projects. And so this was substantially more funding, but fewer projects were selected for this. So there were 5 selections there. And then finally, topic area 3 was a very significant level of funding to actually begin the process of permitting and developing and ultimately constructing and operating 2 larger scale hubs. And so maybe Climeworks will talk about one of the hubs that they were awarded as part of this. But very, very exciting to see what will happen there. So the first 2 topic areas are managed primarily by FECM, my office. Topic area 3 is managed by the Office of Clean Energy Demonstrations. So very excited. These projects are kicking off, and we're very excited to see how they come together. I just want to share this map quickly about the different sites around the country where these hubs have been chosen. So there's a lot going on here. You don't have to read every last box. And I'll note as well that specific sites have not necessarily been chosen. Any of the locations shown are subject to change. But this just gives a broad overview of the geographic diversity and the general portfolio diversity of these different hubs. So very excited to see how these shape up across the country. And there's a lot of different DAC technology developers involved across the hubs as well, taking a wide variety of approaches to developing direct air capture. So Yeah, just quickly, I'll touch on some of the other things that were funded by the bipartisan infrastructure law. So we had these pre-commercial DAC prizes. So we awarded some startups shown on the left and some accelerators shown on the right in cities around the country to help advance DAC entrepreneurship and get some, more early stage companies formed and up and running in this area. Because I mean, a lot of these there are major incumbent corporations, large energy companies or chemical companies that are interested in DAC, that are investigating it, but a lot of the development will happen and has happened from what are or were relatively small startup companies. So ensuring these companies, are entering the pipeline and developing appropriately is key. So we're excited about those. We also, with some of the prize competition funds, we did the purchase pilot. So carbon removal, the business model, at least right now, is largely centered around selling carbon dioxide removal credits. And the question is, who buys those? And so there's the voluntary carbon market where corporations buy them. But the government is now interested in purchasing these as well. So we piloted this through this CDR purchase pilot. Several DAC teams were selected as semifinalists from around the country. And so we will see as their proposals develop throughout this competition, what we can do there. And we're very much hoping this will be successful and valuable for the industry. And we've secured further funding to do more rounds of CDR credit purchasing. So excited to see how this develops and comes together. Recently announced, we have the DAC Commercial Pilot Prize. So this prize was just launched last week, and it will award DAC developers as they progress from relatively small scale systems to pilot systems of, say, 500 to a few thousand tons per year, which is kind of the natural step on the way to these so-called mid-scale facilities of, say, here I have it listed, 5 to 25,000 tons per year, which is the next kind of stop on the way to these large scale commercially relevant demonstrations. So we're very excited about I'm saying we're very excited about a lot of things, but it's true. Like we are very excited about all of these different programs that we have going on. But the DAC Commercial Pilot Prize really is an important part of ensuring that DAC companies kind of at this small scale pre-pilot phase can secure the funding they need to get to the next phase. So happy to talk more about the prize during the Q&A. So I'm just going to quickly touch on the NETL DAC Test Center. So in Pittsburgh, we're deploying, or we funded at the National Energy Technology Laboratory facilities, this DAC Test Center, where DAC developers from all over the world can engage with leading scientists at NETL for testing and development of their materials. This is very helpful, so companies don't necessarily have to invest as much in these testing resources internally, and there can maybe be a bit of shared infrastructure and shared expertise here. So we have several different scales at which companies can engage, all the way from the material scale up through these larger prototype scales, which can be tested in environmentally relevant conditions, which is key for properly developing DAC technologies. So just wanted to raise this. Happy again to talk more about this in the Q&A, but we've had several agreements signed between private companies at developing DAC technologies in the DAC Test Center. So the goal is to support continued development with that. So I just have a couple of more slides here, and so I spent through the previous two so we could focus a little bit here on what's the role of states. What are some opportunities available for states? So I know this slide has a lot on it, and we can definitely revisit this and send the slides out after for review. But I just listed a few ideas here of the kinds of things that states can think about doing to support direct air capture. So this first one has to do with demand side and regulatory support. So integrating DAC into compliance markets, as California is sort of investigating through SB 308 right now, is interesting. Perhaps even directly purchasing DAC credits could be an interesting area to explore, similar to what DOE is doing with the purchase pilot. Regulatory support for geologic CO2 sequestration is also important for DAC companies, so they can have clarity and permission to inject CO2, which is ultimately necessary to actually remove CO2 from the atmosphere and to generate the credits that they need to sell. Community engagement is part of this. States are in a position where they can maybe help uncover and communicate, or perhaps even enforce community desires around these facilities, and say, okay, well, what do people in a local area, what do they want from a plant? What kinds of rules does a new DAC project have to follow in order to be tolerated in a community and to actually benefit that community that it's cited in? Workforce and company development. So as I noted on the previous slide about the spectrum of DOE's DAC work, workforce development kind of underlies everything, all the way from chemists in the lab creating these sorbents to the truck drivers who are delivering, sorbent replacements to the sites and so forth. So yeah, anything that can be done in terms of developing the people and educating the people who will be necessary to, staff this industry is important. Roadmap development. So states around the country are developing roadmaps for how they might be able to reach carbon neutrality, or perhaps, or maybe just, certain emissions targets they may have. So yeah, incorporating carbon dioxide removal in those roadmaps is scientifically accurate, but also helps send a signal to the broader business and policy communities that this is a necessary development. So that's helpful. And then innovative ideas, I just listed a few things that sometimes come up: public-private partnerships, community-based ownership, low-cost loans, just some ideas of other ways that governments might be able to help spur development here. So yeah, we can chat more about those in the Q&A. Just quickly on this slide, I list a few specific programs that states may be able to directly apply to. We have the utilization procurement grants ongoing, and this is a little bit more in the carbon conversion division, but it's funding for states and local governments and such to procure goods made with captured carbon. So there could be some DAC crossover there. It's a new voucher program we have going on through the Office of Technology Transitions, which can provide technical assistance and support for various aspects of commercializing clean energy technologies, but carbon management is one focus area. And I listed a few other links here that can be of interest. So yeah, you can click through these when we send the slides out. But anyway, yeah, that my presentation. So I just, yeah, we'll reemphasize here. PCM and NASEO, we leverage decades of experience, point source captured for DAC. Work on a wide range of technologies to hedge against the risk of any particular one not working out. And then, of course, many stakeholders will need to be involved in creating the DAC ecosystem in the US. So thank you very much. And yeah, I know it says questions here, but yeah, we'll take questions at the end. So thank you very much.
Thanks so much, Grant. And yes, we'll be sharing his slide deck with all the attendees next week. I'll hand it over to Andrew now.
Thanks so much. Pulling up slides. Sorry, technical difficulty. Try this.
No worries. If you need to send them to us, happy to pull them up. Oh,
Did that seem to work?
Great.
Okay. Thanks very much. Really appreciate the opportunity to be here. Apologies for the scratchy voice, getting over COVID at the moment. It was really a privilege to host the NASEO and FECM group in Iceland not too long ago. And yeah, I'll be really delighted to present a bit about Climeworks, about our work, how we fit into the broader CDR policy and technical environment. And Grant really set the table very well. I'd also like to say that companies like Climeworks, we've been on a journey from small Swiss startup in the lab in 2009, now with a very strong focus on scaling up and commercialization in the United States. And that is largely driven by policies like those that appear in the Bipartisan Infrastructure Law, the Direct Air Capture Hubs program, certainly for significant capital expenditure support, also tax credits in the IRA. Really just to drive home the point that Grant made, that there are very important ways that policies can drive deployment and commercialization. I think certainly on the federal, but also the state level. So my focus is North America government affairs and policy to really enable our project deployment. And so, direct air capture, I think is as Grant put it, maybe a brute force way of solving a vital piece of the climate change puzzle. This is a chart that many of you may have seen, but really it's just to illustrate and underline that in order to reach net zero emissions, we need negative emissions. And that's the portion of the darker blue that you see below zero. If we're going to actually meet our climate targets of 1.5 or even 2 degrees Celsius of warming this century. And direct air capture has a role in this because it's a highly measurable, scalable solution that takes CO2 straight out of the air. And our business model is to indeed become, climate relevant, I think was the phrase that Grant used, to scale up to billions of tons of carbon dioxide removed by about mid-century. And so our business model is really, the core is to address climate change. That's why the company fundamentally exists. And we can get into a little bit of the market dynamics and how we've been doing since 2009. Next, I wanted to show a very basic, but I think maybe important slide that I always show to just really illustrate clearly the difference between carbon dioxide removal and point source carbon capture. These are complementary but fundamentally different technologies with different purposes. So with carbon dioxide removal, we indeed are generating negative emissions, whereas point source carbon capture is preventing emissions from going into the atmosphere. So the atmosphere, when you get close to net zero, starts to feel the difference. Until then, when we take CO2 out of the air versus when we don't emit it, the atmosphere is feeling sort of the same benefit. But really, again, these are complementary technologies, specifically direct air capture, paired with geologic storage and point source capture, because they will really grow up together, sharing the same infrastructure and a lot of the same types of policy supports that exist, certainly the 45Q tax credit. So how does our technology work? Well, Climeworks was founded by 2 German engineers doing their PhDs in Switzerland that wanted to find a scalable solution to climate change. And they settled on direct air capture as a potential way to do this, fundamentally using a special filter material to take CO2 out of the air. So air is pulled into what we call a collector container. There's a filter material inside. It's an amine-based sorbent. The CO2 molecules stick to it. When the filter is saturated, we stop sucking in air and close the doors, apply steam, low-grade heat, about 100 degrees Celsius, which breaks those chemical bonds between the CO2 and the filter material. And then we use a vacuum pump to suck the steam and CO2 out. Then we use sort of off-the-shelf, if you will, gas separation techniques to separate the steam from the CO2 and treat the CO2 for storage. So we have 2 notable plants that I want to highlight that are the world's first direct air capture and storage plants. If you've seen a picture of a direct air capture facility, you've probably seen Climeworks. So this depicted here is our Orca facility. This has a 4,000-ton nameplate capacity. It's the world's first direct air capture and storage facility located in Iceland, running off geothermal heat and power. Why is geothermal well suited? Well, we require heat, as I said. That's about 80% of the process, the steam. The rest of the 20% of our energy demand is to run the processing equipment and the fans. So geothermal provides a great low carbon solution for both of those energy needs. Fundamentally, because we are producing negative emissions, we have to deduct all of the emissions, what we call gray emissions, that go into the process of creating our carbon dioxide removal. So everything from the commissioning of the plant, running the plant, any losses therein, all the way through decommissioning the plant, we deduct all of the carbon emissions that go into that before we ever sell a ton of carbon dioxide removal. So this plant has been running since 2021. One of the themes that I'll touch upon is that it's very important, it has been very important for Climeworks to develop the technology, calling back to what Grant was saying about the TRL levels, both in the lab scale, developing our own sorbent technology and continuing to test that, but also deployment in the field fundamentally. And Iceland is not necessarily an easy place to deploy technology and to build it. The next step up from Orca is a 9 times larger facility called Mammoth in the same location. So this, you can see a recent picture. Some of the collector container units are up and running. We inaugurated this facility in June of this year. And when it's fully operational, it'll be a 36,000 ton nameplate capacity facility. So really, we took learnings from Orca, learnings that we never expected to get in terms of how certain equipment performs in the cold, in the wet, over the winter, with different wind patterns, et cetera. We took those learnings and applied them to Mammoth to introduce quite a bit of additional efficiency. And to give you, an idea of size, the Orca plant here, including the process hall in white that you see on the left, is about 100 feet on a side. So really not very large. This is approximately 10 times larger. When we look towards megaton scale, million ton scale, that we'll get to a little bit later, and that's what Climeworks is working on in Louisiana under the Direct Air Capture Hubs program, building towards a megaton facility. For us, that's going to be less than 100 acres. So in terms of bang for buck, land use, and not needing to compete with arable land for or other land uses that would be better suited, direct air capture is quite efficient in that regard. This is just a close-up. You see here there are 6 chambers within each collector container. Each of those containers is the size of a 40-foot shipping container. Again, this speaks to our modular design in easing manufacturing, transportation, et cetera. And you see the steam blowing off the back there. That is just the excess steam after one of the chambers has been desorbed, where the carbon dioxide and steam has been vacuum pumped out, and that's just a little bit of the remaining steam coming out of the back. I think this is just kind of a cool picture to illustrate that, and underline the point that in order to deploy something successfully, like these commercial DAC facilities, you have to do it in all conditions. And indeed, Climeworks has been testing our technology in various climatic conditions over the years. Iceland is not, it's not the easiest place to build something. Supply chain and other considerations come into play as well. Workforce is something that Grant mentioned, which is also very important in determining where to site DAC projects. But really, you have to learn through deployment again. And we are, as Grant said, at the early innings of the industry. Climeworks may have been around the longest, since 2009, as I mentioned, but we are still very much in the early innings. So what's the business model? How do we pay for this? Essentially, we sell carbon dioxide removal credits. So these are like carbon credits in that I think everyone's familiar with, but as I mentioned at the outset, carbon dioxide removal is fundamentally different from carbon avoidance or carbon reduction. Excuse me. So it's quite important, I think, in looking at as the development of the carbon dioxide removal market takes place, that we create clear rules of the road, boundaries in terms of what is the magnitude of the market that we seek to serve here, not confuse and in any way slow down climate mitigation by by investing in carbon dioxide removal. So what we do is we sell carbon dioxide removal credits to the voluntary carbon market for companies to offset their otherwise unavoidable emissions. Here's a smattering of the companies that are involved. Grant mentioned there's very important efforts underway at the federal and at the state level to advance procurement and integrate carbon dioxide removal into compliance markets. So that's something I'm very happy to speak to later in a bit more detail. We also do sell carbon dioxide removal as a service to individuals. So if anyone's interested in joining the ranks of Bill Gates and Coldplay and offsetting your own personal unavoidable emissions, you can buy CDR on Climeworks' website. Company snapshot, we're about 500 strong now. The operational experience, more than 120,000 hours in the field and counting, is something we're very proud of. Pretty well capitalized at 810 million USD raised, and always striving to keep our life cycle emissions very low. Again, and I'll get to this in a slide or two, but one of the key ingredients for direct air capture is low carbon energy inputs. So as I mentioned, we've been testing our technology across Europe and in various locations for quite some time now. So what do you need to make direct air capture successful? You need land, you need some place to build your DAC. You can do that anywhere in the world on the capture side, because CO2 mixes so quickly and evenly in the atmosphere, but you need proximity to where you're going to put the CO2. You don't want to have to build a long pipeline. You're also going to need to have the regulatory frameworks in place to properly and safely store that CO2 permanently underground. You have to have low carbon energy. You have to bring costs down through technology advancements and through economies of scale. And there has to be a market that's ready to support the industry as it grows. So this gives a quick overview, really just to illustrate that the storage potential, the geologic storage potential for carbon dioxide is vast, and that with the right types of policy frameworks, there's plenty of capacity to store all the world's historic emissions, several times over. We're on track, Climeworks is, to scale up towards million-ton scale. And I would just call out that we're very focused right now, as I mentioned, on commercialization in the United States, getting to million-ton scale. We feel like about the fastest you can go in a hard technology industry like this is scaling up 10x every 2 to 3 years. That's what we've done and demonstrated thus far. So we're at 36,000 ton scale now. We aim to be at million-ton scale in the 2030s with a direct air capture hubs project called Project Cypress in Southwest Louisiana. We're also involved in 2 Topic Area 2 projects under the direct air capture hubs in Kern County, California, and in North Dakota as well. The energy piece that I keep mentioning, it's a part of the puzzle where you need to put together your storage and you need to put together your energy. And it's geothermal, like we have in Iceland, is not universally available, of course, although there's very interesting advancements in the United States taking place now with solar and wind and intermittent resources without utility scale storage. It is a challenge. At this stage of the development of the industry, we really want to be running our plants all the time, even though technically speaking, that's not absolutely necessary. And looking for opportunities for heat integration with other industries is really important. So the energy side of the equation is really critical. I think there's a lot that the federal government, states, and local authorities are doing to look very carefully at the siting and permitting and including the transmission of electricity. So as Grant mentioned, getting the cost of direct air capture down is really, really vital. It is very expensive at the moment. It is the highest quality carbon dioxide removal on the market. A ton is not a ton at this stage of the game. But when you can directly measure it, meter it, and have it third-party independently certified, as we have at our Orca facility, you can be quite confident in the quality and the integrity of that. So we're projecting, and these are real projections, that we can get down in the 2030s to a $400 to $600 range of cost, and getting down towards more like a $200 $250 range by mid-century. And by mid-century, we aim to be at billion-ton scale. A gloss over this just gives you an idea of how the different technology generations worked. We're actually now in parallel to deploying the Generation 2 technology, actively working on deploying our Generation 3 technology. Again, these are really driven by our learnings from the field as well as in the lab, but primarily learning through deployment. And this is a rendering of what our project in Louisiana, Project Cypress, would look like. So you see it's in a bit of a different format from what you saw, the photos you saw of Orca and Mammoth. It's in a cube format. And so this, again, would be less than 100 acres total. Zooming in on the cube gives you a little bit of an idea. We've learned that it would be more efficient to organize our collectors in this way, more energy efficient. And indeed, our testing data is showing that we can achieve 50% lower energy consumption and 50% higher, double the throughput. So these are significant cost savings just from designing the modules a little bit differently. These are, I think, common goals that will be shared by any direct air capture developer as they advance on their journeys. Again, these are the things that we're working on. Certainly increasing the filter material lifetime is something we're working on with our lab. We have 180 people of our 500 devoted to technology, some 65 of which are totally dedicated to the sorbent, the filter material. Here's a view of what our large-scale testing facilities look like in Basel, Switzerland, and we will also be building a cube to validate everything put together. And here's really a trajectory that we think is maybe instructive to look at. While we do have very ambitious goals, we see the development of direct air capture that could take, with the right kinds of government policies, the same trajectory that solar PV has done. And looking at the cost of CO2 abated versus removed, in those terms, in 1995, solar was quite high, approaching $1,000 a ton, just as we are today with direct air capture. But that glide path really, up until a couple of years ago, has been very dramatic. So I think that's it. I would just want to say a note on our community engagement and some of the themes that Grant touched upon. So it's been really vitally important to be very open and I think, frankly, sensitive with the communities that we want to develop projects in. That's not unique to the United States, but I think is very has shown to be very fundamentally important, especially when looking at building in an energy community, a community that has had mixed positive and negative experiences with legacy industries. So it's been really important, and I think the requirements to produce community benefits plans that come along with the federal cooperative agreements like the Direct Air Capture Hubs program have provided a very interesting and forward-looking framework for that to happen. I can share that at a fundamental level, there's a lot of education that needs to be done in all communities about what direct air capture is, what it isn't, how it fits into the equation, how it fits into a cleaner energy future. I think we've learned that that having meaningful engagement on a one-to-one basis and on a personal level, and allowing folks to ask questions and really have an open conversation has been really constructive in this space, but we have a long way to go. Thanks so much.
Thanks so much, Andrew. Really great to hear more about what Climeworks is doing in the US. I think we have about 8 minutes left for Q&A, and I saw one just come in the Q&A box that we can start with, and then have a few others that I wanted to get to. But there was a question that says, when you talked about billions of CO2 removed by 2050, is that per day, or what is the timeline there?
From our side, that's per year. Sorry, I should have specified. The capacities that I mentioned are per annum. So to maybe characterize the magnitude of the problem, right now we have globally something like 40 to 50 billion tons, gigatons of carbon dioxide emissions, never mind other greenhouse gases, per year. So if we're looking at a very steep curve of reducing those emissions over time, looking towards 2050, if we really cut those emissions drastically, we would still be looking at probably a minimum of 2 to 3 billions of tons of carbon dioxide removal, negative emissions needed to get to net zero at that stage. And it could be upwards of 15. There's quite a range that we could be looking at. And so we would be looking at direct air capture filling potentially close to 1 billion tons of that pie.
Thank you for clarifying that, Andrew. And Grant, maybe one question for you, building off the TRL readiness level chart you showed. Something we've heard from states is with new technologies, there's a lot of concern about getting over that technological valley of death between initial innovation and commercialization. Is this something DOE is looking to help mitigate, or do you see this as a big concern for the DAC industry?
Oh, yeah. I mean, I think it's applicable not just to DAC, but really any kind of new clean technology, but even beyond that, any kind of new technology or even business. There are some different charts and analyses out there that show like the number of businesses or like the number of startups that fail. And depending on what stage they get to, that percentage varies. But an often cited one is like, 90% of startups fail or something like that. Or I think I've seen 75% as well. And if you really look at the funnel of like how many business ideas people have to like how many actual, functioning profitable businesses that end up getting implemented as a result of those ideas, it's like a huge funnel. So I think it's just, it's just the nature of innovation, that there's going to be so many different ideas, so many different proposals. Only a number of them, get to that next stage of getting a little bit more serious, and then it gets whittled down as you get to more and more workable things. So yeah, I think, and then if you think about technologies in that way, the question becomes, well, then, okay, how do we get more successful technologies? And so you could think about, well, how do we increase the pie? How do you get more, ideas and innovations kind of coming into that funnel? But then you also think about, well, how do we create the conditions or provide the support such that more things get through that funnel? How can more technologies get to that next stage? And so, like in terms of DAC in particular, when DOE provides support to these DAC technologies across all these different technology readiness levels, theoretically that should help some of these projects, or at least some fraction of the projects, make it when they otherwise wouldn't. And that's kind of the catalytic impact. So, but yeah, with DAC, I mean, like we were just talking about, if ultimately there will be, say, a billion tons of DAC, globally per year, the question is, what's the most cost optimal portfolio of that going to be? And I'll just quickly note that it's not so simple as to say there will be one company or one technology that is the one that wins. And one reason for that is because there's different climates all around the world and different DAC technologies function differently in different climates. And so there might be some certain regions, as demonstrated in this report that Lawrence Livermore National Lab and other collaborators put together, called Roads to Removal. Like there are probably some regions where DAC's like more workable, and other regions, particularly ones with an abundance of low carbon energy and geologic storage. Like if you don't have those things, it's going to be hard to make it work. But even within those kinds of areas around the world, there's very different climatic conditions in terms of temperature, pressure, humidity, precipitation, those kinds of things. And different types of DAC technologies function better and will provide lower costs in these different regions. So yeah, there's going to be some really interesting optimizations that occur across the whole portfolio over the next couple of decades. But yeah, I mean, we're all trying to drive toward the most economically efficient and optimal means of doing this.
Thanks, Grant. And maybe jumping on your reference to some of the incentives and market opportunities for DAC, do you both kind of see the direct air capture regional hub funding and the 45Q tax credits as kind of enough to get most of these regional projects across the finish line? Or do you think there will be a need for states to help supplement with additional funding or private sector funding?
Yeah, Andrew, do you want to comment on that first, and then I'll jump in?
Sure. Yeah, I think, it's a hard question to answer because the field is so new, really. But I think the funding and the policy setup under the infrastructure law and IRA are transformative, catalytic. Is it, are they together going to result in, 4 megaton hubs? Which is, as Grant said, the stated goal. That remains to be seen. I think it's very challenging. I think there's very, maybe to be more direct, I think there is a very important role for states to play on the demand pull, but also potentially supporting project developers, on the permitting, regulatory, and maybe even funding side of things to kind of fill out the puzzle. Yeah, really, really important. And doubling down on what Grant mentioned about SB 308, which is in action right now. I think it's in the Appropriations Committee today or tomorrow in California being considered.
Yeah, I'd echo that too. I mean, yeah, it's definitely super valuable. Like without the DACOPS program, without 45Q, it wouldn't be as far along. It just wouldn't be. But with that said, I mean, 45Q, at least right now, provides up to $180 per ton of per gross ton of CO2 captured from the atmosphere and stored if you are actually storing it. But yeah, as Andrew showed on the slides, and it's generally expected across the industry, I mean, costs of doing DAC today can be upwards of $1,000 per ton. So 45Q is important, but it doesn't solve everything. And the DAC hubs funding is obviously, I mean, that's my program. Like and I'm the PM for, at least for the FECM equities, and it's like I love it and it's amazing. But yeah, especially if you look at the topic area 3, it's a 50% cost share, which is tremendous. But still, there needs to be private capital, and then the demand piece still needs to be solved. And when we have these facilities, tens of thousands, hundreds of thousands, millions of tons per year. If each one of those is several $100s, perhaps up to $1,000 per ton, I mean, we're talking markets that are hundreds of millions, billions of dollars per year to start. And so, yeah, those markets. The voluntary carbon market, in terms of its interaction with carbon removal, needs to grow. Maybe we'll see more federal things there, more state things. But yeah, they're definitely, these things are great. It's an all hands on deck effort. We certainly need more to make it work.
Great. Well, right on time. Thank you so much, Andrew and Grant, and again to FECM for their support of this webinar. We'll be sharing the material shortly, and just a reminder for anyone who will be attending the NASEO annual meeting this fall in New York City, we will be having a plenary session on direct air capture. So hope to see many of you there. Have a great day.